Alright, this is a question on falling with air resistance. So, you're asked to explain why the initial vertical acceleration of the parachutist is 10 meter per second square, which is free falling acceleration. So, when the parachutist steps off a plane, the initial velocity is 0 because he just stepped off the plane. So, in the initial stages of parachutist fall, there is essentially no or very little air resistance because the speed of this parachutist he's speeding up, but the value is very, very small. So when the speed is very small, the effect of air resistance is very, very negligible. So for a parachutist in the initial stages, it is similar to something that is free falling, and hence the acceleration of a parachutist in the initial stages is 10 meter per second square, which is gravitational acceleration. Now, this effect only lasts for a short while though, because as the parachutist falls, he or she will speed up, and then the effect of air resistance will become significant. Now, in part B, what happens when the parachutist opens his chutes? So, the parachutist will slow down, and the reason for this is because as the person opens the chute, immediately the surface area becomes very, very big. And when the surface area becomes very, very big because of the parachute, the air resistant force suddenly becomes a very, very big value. So if I draw a free body diagram, this is the free body diagram of the parachutist when the parachute just opens. The person is falling, there is a downwards weight that remains the same, and but suddenly the upwards resistant force becomes humongous, and I have represented that using a very long blue color arrow. And we can see that this is the resultant force of the parachutist. It's an upwards direction, and as the parachutist is moving downwards with an upwards resultant force or an upwards acceleration, this means that this object must slow down. That's the reason why the parachutist slows down as he or she falls. Now, what happens next? The air resistance will gradually become smaller. Remember that the person is slowing down. So as the person slows down, the resistant force will decrease accordingly. When you run more slowly, the wind in your face becomes weaker also. So there will come a time where the air resistant force becomes smaller and smaller until it matches the value of the downwards weight. So in this case, there is no resultant force anymore, and the object, the parachutist, was falling down. Therefore, it will continue to fall down, and it will move at a constant velocity. This is the idea of terminal velocity.